Hello again, it's Mr. Martin. Today we're going to do 5.6 related rates. So this is page 257. I just picked out two random ones, number 11 and 15. So the first one says a spherical balloon is inflated with helium at a rate of 100 pi feet cubed per minute. Our book didn't give us the formulas, but these are the formulas that we're going to use. On the AP test, it will definitely give you the formulas, so you don't have to worry about memorizing those. You just have to worry about everything that's in the problem. So a spherical balloon is inflated with helium at a rate of 100 pi feet cubed per minute. So some clues onto this one that tells us what this 100 pi is that this is in feet cubed, which is a volume, and this is a minute. So this is the rate of the volume. So I would start off by going, okay, this is dV dt equals 100 pi. So now this one says, how fast is the balloon's radius increasing at the instant r equals 5? So how fast is the balloon's radius increasing means we're looking for dr dt. So we want to find what dr dt is. So we know our volume, and so we're going to use our volume formula. We take the derivative of that, which is dv dt equals 4/3 pi r cubed. 4/3 pi is a coefficient. R cubed is 3r squared. So this gives us 4 pi r squared. We've taken the derivative of r, so we have to make sure we note that here, dr dt. Now, dr dt is what we're looking for. We know our radius. We know our dVt. We are basically at our answer. So we have 100 pi equals 4 pi. R is 5, so 5 squared, dr dt. So this gives us, 100 pi, 100 pi. I'll move this up here. We get 100 pi equals 100 pi dr dt. So we divide by 100 pi, and our dr dt gives us 1. Now what does this 1 mean? We have to go, this is the change in the radius. The radius is measured in feet, and then the change in the time, which is minutes. So this is 1 foot per minute. So our answer is 1 foot per minute. Okay? With these related rates ones, you just got to start doing something. You can't just sit there and look at it and try to figure it out. A lot of times, just start and take a derivative, stuff will cancel out. The next question says, how fast is the surface area increasing at that instant also? So how fast is the surface area is SA dSA divided by dt. So we want to find this is when our radius, at that instant, our radius is 5. So our dSA dt equals 8 pi r dr dt. Okay, so if we go in here and we're doing it at r equals 5, we already know our radius is changing at 1 feet per minute, so that's our dr dt. Our r is 5, so dSA dt is going to be 8 pi times the radius, which is 5, times dr dt, which is 1. So this gives us 40 pi. Okay, and then we look back at here and we go, this is surface area. So we're figuring out the surface area. Surface area is feet squared per minute. A lot of times on the AP test, those units will be 1 point. So you always want to make sure you get those correct. All right, 6-inch deep cylinder, increasing the radius 1/1000th of an inch. 1/1000th of an inch is 0.0 tenths, hundredths, thousandths of an inch every 3 minutes. How rapidly is the cylinder's volume increasing when the diameter is 3.8 inches? This one's somewhat of a rough one, I think. All right, so 6-inch deep cylinder. There we go. We got a cylinder right there. 6-inch deep cylinder. 6-inch deep cylinder. Increasing the radius 1/1000th of an inch. I wrote this down, but I feel like I'm missing something. So 15 says the mechanics at Lincoln Automotive are reboring a 6-inch deep cylinder to fit a new piston. The machine they are using increases the cylinder's radius 1/1000th of an inch every 3 minutes. How rapidly is the cylinder's volume increasing when the bore diameter is 3.8 inches? All right, so we actually didn't miss anything. So what's happening is this is a cylinder in a car, and they're basically it's made out of a solid brick. They're cutting a hole in it, and they're just making that hole bigger. So our radius right here is 3.8 inches. But because we're making this hole bigger, the 3.8 inches is changing, and that's increasing the radius 0.01 thousandth of an inch. So our dr dt equals 0.001 inch every 3 minutes. Okay? So we want to figure how rapidly is the cylinder's volume increasing when the diameter is 3.8 inches. So our radius is going to be that. We're looking for how rapidly is the cylinder's volume. So we want dV dt. So our volume of a cylinder is pi r squared times h. Because we're only increasing the radius, we're not worried about this changing. So our h is actually going to stay the same. So our volume is going to be pi r squared times 6. So dV dt equals 12 pi r dr dt. So our dV dt is what we're looking for. dV dt equals 12 pi r. Our r is 3.8 inches. And then our dr dt is 0.001. So we're going to punch it in our calculator real quick. I'm going to leave the pi in there. So I got 12 times 3.8 times 0.001. We get 0.056. So this dV dt is increasing at 0.0456 pi. And then we look back at this. This is inches for every 3 minutes. So this is volume. So inches cubed, but it's still every 3 minutes. So the thing you got to look for is on the AP test, it may switch this into per minutes. So in order to do that, we'd have to divide this by 3 to change that into 1 minute. Now, hopefully you guys are okay with this related rates. They're really not that hard if you just start doing the problem, and everything will start to work out. All right, guys, as always, email me if you have any questions.